Hi. Starting from React version 16.8, hooks have become a part of our everyday development. This functionality has sparked a lot of debates, and there are reasons for it. In this video, we will discuss one of the most common misconceptions about using hooks. Let's consider two options for writing a component. The first option is to use classes. In this option, we added a method to the class, and when an instance of the class is created, this method is created once, and in the render, we already use a reference to this method. Thus, with each render, we always refer to the same reference and do not recreate the class method. This construct was familiar and understandable to everyone who has been in the profession for a long time, even if you recently came to React from another programming language. The second way to create a component is by using a function. In this approach, to create an on-click handler, we define the body of it directly inside the render because the entire function body is the render itself. There is no other option if you want to use props. And here is where we start to feel uncomfortable. How can it be that we should create a new function on every render? It seems like a step backwards compared to classes. To deal with this issue, I went to the React documentation in the question and answer section and found the following question. Are hooks slow because of creating functions in render? No. In modern browsers, the raw performance of closures compared to classes doesn't differ significantly except in extreme scenarios. In addition, consider that the design of hooks is more efficient in a couple ways. Hooks avoid a lot of the overhead that classes require, like the cost of creating class instances and binding event handlers in the constructor. Idiomatic code using hooks doesn't need the deep component tree nesting that is prevalent in codebases that use higher-order components, render props, and context. With smaller component trees, React has less work to do. According to the documentation, creating a class instance for React is such an expensive operation that creating a function for each render is orders of magnitude cheaper. Moreover, the fact that the tree becomes deeper when using higher-order components like Redux's Connect or MobX's Infinite Observers is not pleasing at all. This idea is a bit difficult for developers to accept because we are used to optimizing everything, and now we need to make the code less optimized than it was with classes. And as a result, we start looking for ways to get back to the previous level of optimizations, and the first thing that is Googled is to start using the useCallback hook, and many people start actively using it in their projects. The question is only how well we understand how useCallback works. Let's conduct a small quiz for this. In one case, we've created a component where it creates some function callback on each render, and we call it when the button is clicked. In the second case, we have exactly the same component, but we've decided to wrap the callback in useCallback. For the user, nothing has changed. Console.log is still called when the button is clicked. So, now the actual question, in which way some function callback created less frequently? Take a minute to think. And the correct answer is neither. Yes, exactly. UseCallback did not give us any optimization. The function is created exactly as many times as before the optimization. Moreover, we actually worsened the performance of our component. What can fool you is the perception that useCallback is some kind of black box, where you pass a callback, something happens with it, and then you have happiness. But let's consider how it actually works. First, let's do a type of check on this black box, and naturally we get function. It was obvious from the syntax. To understand how the black box works, let's write the useCallback implementation ourselves. This is a function that takes two parameters, callback and deps. Next, we need to store this callback in dependencies somewhere so that we can return the same callback function on each subsequent call. Now let's consider different cases. If the dependencies do not exist either in prev state or in the new data, then we need to save the current parameters and return the callback. But if the dependencies exist, then we compare the arrays using a certain function, and if they match, we return the memoized function. And if the dependencies do not match, then we again save the parameters and return the current callback. It seems like we have covered all the cases. What conclusions can we do from this? The useCallback function, like any other function, is called on each render, and each render receives a new function and a new array of dependencies as a callback parameter, which we either throw away if the dependencies before and after are equal, or save them in the repository for future use. Let's now look at this function from the component side. Now we know that useCallback is just a function, and we can extract the passed parameters into own variables. Here it becomes quite obvious that we create not only a function for each render, but also an array with dependencies, and then pass all this to useCallback. If we just comment out the dependency creation and the useCallback call, and pass the callback parameter directly to onClick, then it seems that the performance of the component should improve because we have removed the intermediary, which was of no use to the performance. To put an end to this story, let's also remove the commented code, and we end up back to the initial situation. When we just create a function for each render, it turns out that in this case, using the useCallback hook does not improve the performance, but rather the opposite. It worsens it. It turns out that we are using useCallback incorrectly. To understand this, let's refer to the documentation. I decided to show you a piece of text from the legacy documentation, because it is better works for our video, returns a memoized callback, pass an inline callback and an array of dependencies. useCallback will return a memoized version of the callback that only changes if one of the dependencies has changed. This is useful when passing callbacks to optimized child components that rely on reference equality to prevent unnecessary renders. The main idea is not to improve the performance in a particular component, but rather it is only beneficial if the callback is passed as props. Let's look at another example. Let's say we have a list of cars that we want to display. We have a cars component that receives the list of cars via props and draws them one by one using the map method and the car component. Here we needed to add a handler for clicking on a car. We create the onCarClick callback and pass it to the car component. And in this situation, for each render of the cars component, we create a new instance of the onCarClick callback. Respectively, no matter if car is a pure component or wrapped in a memo, all cars will always be re-rendered, because they get a new instance of the callback each time. This is what useCallback is for. If we wrap the callback in a hook, then we will have a memoized callback returned in the onCarClick variable, even though we pass a new instance of the callback into useCallback for each renderer. Thus, all car components will not be rendered unnecessarily, because the reference to the callback will remain the same. And if we look inside the car component, there we will create another function that will link onCarClick and the car object. In this case, there is no use of wrapping the callback in useCallback, because we don't care whether it is a reference to a callback from the previous render or from the current render, and useCallback, as we already know, is not free. This video can be summarized in the following words. Although React supports components as classes, it has more maneuvers over acceleration of components as functions, and the ecosystem itself is increasingly providing you with hooks as APIs, which is impossible to use in classes. And of course, trust React. If they said it's better to create a callback for every render, do it, because they are only interested in improving the performance of your project. And if you liked our video, be sure to share the link with your colleagues, press the like button, and subscribe to the channel. There will be a lot more interesting things here. Bye.